So, continuing from our previous lecture on the evaluation metrics, so the previous lecture was on regression. So, continuing on the previous lecture on evaluation metrics, mean squared error is the average of the squared differences between the predicted and the actual values. Now, root mean square error, the square root of the mean squared error, providing error in the same units as the target variable. Now, mean absolute error, the average of the absolute differences between the predicted and absolute actual values. Mean absolute percentage error, the average of the absolute percentage differences between the predicted and the actual values. Used when the scale of the target variable varies. Now, explained variance, a metric that indicates how much of the variance in the target variable, how much of the variance in the target variable is explained by the model. So, how much of the variance is explained by the model. Now, a Kaike information criteria, a metric used to compare models, taking into account both goodness of fit and model complexity. So very important. Bayesian information criteria, it is similar to AIC but includes a stronger penalty for models with more parameters. Okay. Now the techniques and the algorithms in regression. So the k nearest neighbor regression, a non-parametric method that predicts the output based on the average of the outputs of the k nearest neighbors. Now, neural network regression. So, regression model based on artificial neural networks, often used for complex and nonlinear problem solving. So, it's a neural network regression. It's a regression model based on artificial neural networks. It's a based on artificial neural networks, often used for complex and nonlinear problem solving. So, in quantile regression, a regression approach that estimates conditional quantile functions, useful for understanding the distribution of the dependent variable. So, it estimates conditional quantile functions. Now, principal component regression is a regression technique that reduces dimensionality by first applying principal component analysis and then performing regression on the principal components. It's very interesting. A partial least square regression, similar to principal component regression, but attempts to find components that both reduce dimensionality and are predictive of the response variable. Very important. Now, generalized linear models. It's a broad class of models that generalizes linear regression. It's a broad class of models that generalizes linear regression by allowing for different distributions of the dependent variable. So it's a broad class of models that generalizes linear regression, broad class of models that generalizes linear regression by allowing for different distributions of the dependent variable. Now, stepwise regression is a method of fitting a regression model by adding or removing predictors based on their statistical significance. Important. Now comes the assumption in linear regression. So, assumption in linear regression, linearity, it assumes a linear relationship between the dependent and independent variables. Now, independence means the observations should be independent of each other. This is very important. Normality, the residuals should be normally distributed. No multicollinearity, the independent variables should not be highly correlated with each other. The independent variables should not be highly correlated with each other, should not be. Okay. Homoscedasticity, the variance of the residuals should be constant across all levels of the independent variables. Then ultimately we arrive at the conclusion of this lecture that these concepts are essential to understanding the concepts and techniques used in regression analysis in machine learning and AI. And regression remains a fundamental tool for making predictions and uncovering relationships in data. So thank you.